Pspice advanced analysis, such as sensitivity and Monte Carlo analysis, are based on tolerances that you define for the parameters of the devices in your design. Tolerances for the nominal value of resistors, capacitors, inductors, voltage sources and current sources can be applied locally at the instance level on your capture schematic. To apply instance-level tolerances on the schematic, select Pspice, Advanced Analysis, Assign Tolerance from the Capture Text menu. Notice that in our design, the Assign Tolerance menu entry is currently unavailable. You cannot assign tolerances at the instance level until you have created a simulation profile. We will create a new default simulation profile called Sensitivity in our project, and will use the default settings for a time domain transient analysis. Now that we have a simulation profile defined, we can select Pspice, Advanced Analysis, Assign Tolerance from the Capture Text menu. It is important to note that assigning tolerances to instances on your schematic is a relatively new feature that was added at the SPB 17.2 ISR 11 release. Assigning these tolerances with the tolerance analysis window will prevent you from opening this design in previous releases of the software. Before the tolerance analysis window is opened, Capture will generate a Pspice netlist for your design. If you cannot successfully generate a Pspice netlist, then the Assign Tolerance form will not be displayed. In the Instance View folder tab of the Assign Tolerance form, we see all of our component instances listed from our schematic. If we select an instance such as C2, the right portion of the form displays the nominal value of 330 microfarads for our C2 capacitor. We can then enter both a positive and negative tolerance, for instance, 10% for the positive intolerance and 10% for the negative tolerance, and pick Apply in the Assign Tolerance form. In the same fashion, we can assign a tolerance to any of the resistors, capacitors, inductors or sources in our design. When a Pspice Advanced Analysis is run, parameters with tolerances will be assigned a random value with a minimum of the nominal value minus the negative tolerance and a maximum value of the nominal value, plus the positive tolerance. The tolerance distribution determines the probability of a value in the specified range being selected. You can choose either a flat distribution or a Gaussian distribution for the tolerances in your design. A flat distribution provides a constant probability from the minimum to the maximum range for a parameter. The Gauss distribution, also known as a normal distribution, selects random values based on a symmetrical bell-shaped distribution where values closer to the nominal value of the device have a higher probability of occurring. After selecting either the flat distribution or the Gaussian distribution, select the OK button in the Assign Tolerance form to save your tolerances and distributions for the individual components in your design. You use the Assign Tolerance form to assign tolerances to the nominal values for the resistors, capacitors, inductors, voltage sources, and current sources in your design.